Alright, solving equilibrium of several forces. So, the question in example 4 says a mass of 20 kilograms is suspended from the ceiling by 2 lengths of rope that make angles of 60 and 45 degrees with the ceiling. Determine the tension in each rope. We need to solve a couple things. Like always, I'm going to draw a picture first to help me make sense of this. So, here's our lovely ceiling. Oh, I can use that shape for the mass. Great. Here's our mass of 20 kilograms. 20 kilograms. And it is making angles. One of them is 60. The other one is 45. Okay. The angles are made with the ceiling. So that's 45 degrees. That's 60 degrees. Okay. So this is essentially what we got. And of course, this mass is pushing the force downwards. Okay. Now, first of all, what I want you guys to know, I know we haven't really talked about it, but we're going to be converting all of these forces into newtons. Okay. So, a mass of 20 kilograms, essentially any mass exerts a force of 9.8 newtons on the ground, especially per kilogram. So what that means is we need to figure out what this is going to be in newtons. So we take our 20 kilograms and we multiply by 9.8 newtons. That's going to tell us our force. And in this case, it is 196 newtons. Okay, so the force heading downwards is 196 newtons. Now, in this question, it also said that, or it's assumed, that this thing isn't breaking the ropes and falling down, nor is it swaying any which way. It's sitting exactly where it is. Think of it like a chandelier. So it's in equilibrium. So, in other words, the tension on these 2 ropes, so we'll call this, I guess we'll call this force 1 and force 2. The tension on those 2 ropes, in other words, needs to be applying a force that is equilibrium to the force heading downwards. So the force essentially heading in the opposite direction. What would the opposite of down in this situation be? Great. The opposite of that would be upwards. So they need to be applying some force upwards of 196 newtons in order for this to be in equilibrium. Otherwise, this force would snap the ropes and fall to the ground. Or vice versa, get flung up through the roof, depending on which is stronger. Okay? So, what we're going to do now is try to create a triangle out of this. Again, I'm going to get the page a little larger, and then we'll zoom in a little after so that we can solve this question. We got red still? Yeah. Okay. So, we know that the force having to go upwards is 196 newtons, or the equilibrium force. Okay. What I'm then going to do is I'm going to take these 2 forces, and I'm going to extend them a little longer because they won't be exactly to scale. I'm going to take this force, or the 2 ropes, force 2 and force 1, and I'm going to create a triangle with this 196 newton force heading upwards. So I take one of these, and I put it roughly there. Now I'm probably going to need to extend it, just like I'm going to need to extend force number 1. So let's label these as we go through. This is again our force 2. And our force 1, which is over here, we're going to take that and create a triangle out of it. Now I'm going to extend it. Hopefully they reach each other. There we go. And that is considered our force number 2. Or sorry, I lied, force number 1. Now, what's important is we have to figure out the angles they make with everything. So, remember, these were hanging on a ceiling. So, in order to help myself out, I'm going to recreate the ceiling they were hanging on. So, I'm going to do it with this dotted line. That force used to make a 45 degree with this ceiling, and this force here used to make a 60 degree angle with the ceiling. Okay? We're going to use those to help us figure out the angles in this triangle. So remember, whoops, that's the wrong one. That force there was making an angle of 45 degrees, which means this angle inside the triangle is going to be what? 45 degrees again. Nice and simple. Okay. This angle here was 60 degrees. Okay? Which means, what would this angle down here be? 30. This one is going to be 30, and if you're wondering why, that's because this angle here would have been 90, and that would have been our little triangle. Okay? So if that's 30, that's 45. What is our large angle of this triangle going to be? What is it? 105? All right. 105 degrees. Great. So we have all the angles in the triangle. That's going to help us out a lot. We also need to figure out what? What is our goal here? Figure out what force 1 and 2 is, or the tension in each of those ropes. So I'm going to zoom back in for this. Jump back down. So I'm going to recreate this triangle quickly. That's roughly our triangle. Turn it on its head a little. Okay, just so it's a little simpler for us to look at. This was 105 degrees. That was 45. I know this one isn't quite to scale. And this one is 60. And the force, or the magnitude of this, is 196 newtons. Great. Because I have 3 angles and one of the sides, I can use sine law to solve both of these. This was force 2, and this was force 1. Oh, yes, thank you. It's not 60, it's 30. Thank goodness we have smart people in the class. Like myself here. There we go. All right. Oh my gosh, I rewrote it again. See what I mean? Been talking too much. Okay, so we have these here. Let's set up our sine law in order to figure this out. So let's call this A, B, and C. Okay, which means the opposite sides would be the corresponding lowercase letters. Sine A is 30. Yes, got that. The opposite side is considered force number 2, or the magnitude of that force, which is equal to sine, we'll say B is 105, and we know that that is 196 newtons, which is equal to sine 45, which is C, which is force number 1. Boom, boom. Okay. So we got that all now. Now, again, with sine law, what we're going to be doing is we're dropping one off. What I'm going to do is split this and solve it in 2 different sides here. Perfect. So let's call this 2 different questions. We'll split sine law right through the middle. In this one, we're looking for sine 30 is equal to... Now, sorry, I'm going to show you a quick trick with sine law. I usually write the sine on top, but because they're equivalent ratios, we can flip the entire law to make it easier for us to solve. So what I'm going to do instead is I'm going to put the force on top. Force 2 divided by sine 30, and I just got to flip the corresponding ratio is equal to 196 over sine 105. Same idea over here. Force 1 divided by sine 45 is equal to 196 divided by sine 105. Now, I'm going on the assumption that you can carry out these calculations. Can someone tell me what force 2 is equal to in this case? 101.5 newtons. Great. And anyone know what our other one's going to be? What it says here. 101.5. And the other one should be about 143. Is that right? Is equal to 143.4 newtons. Okay. So let's jump back up. Look at the entire page. No, it's kind of hard to see. Force 1 was 143. And force 2 was 101.